In this video, we are going to demonstrate knowledge of relationships between congruent arcs, chords, and angles, and apply properties of tangents. So congruent arcs are two or more arcs that are going to have the same measure. So when we're talking about this, we're talking about the degrees that the arc is taking up in a circle. In a circle or congruent circles, if two arcs are congruent, then their central angles and their chords are also congruent. So if we have two congruent arcs, TI and GE, those chords are also congruent and the central angles are congruent, which means if we know one of them, we know them all. So we know that the arcs, the chords, and the central angles are congruent. In number one, given circle O, we want to solve for x. So if I look at this, I see that this is a crossing lines, which creates vertical angles. So our vertical angles are congruent, which means that these arcs are congruent. So we would have 3x plus 13 is equal to 11x minus 35. Then I go through and I solve for x. So 8x would equal 48. Divide by 8 on both sides, so x is 6. Then it also wants us to find the measure of CE. So I can substitute that into either arc. So I can do 11 times 6 minus 35. And I would get 31 degrees. Well, if CA is a diameter, it's creating a semicircle. So the measure of CE is going to be 180 minus 31, which would be 149 degrees. In number two, we want to solve for x and find SU. So because it doesn't have an arc above it, we're looking for the length of this chord. So before I do that, I need to know what x is. So x is on the chord pieces. Well, because these arcs are congruent, these chords are also congruent. So we would have x squared minus 3x equals 4x minus 10. So I can move everything to the x squared side. So x squared minus 7x plus 10 is equal to 0. So that would factor to x minus 5 and x minus 2 equals 0. So x is 5 and x is 2. Because both of those solutions work, we're going to have to find SU twice. So if x equals 5, SU would equal 5 squared minus 3 times 5, which is 25 minus 15, so that would be 10. And if x equals 2, SU would equal 2 squared minus 3 times 2, which would get us a negative number. So that means that the negative 2 won't work. Number 3, given circle WI is a bisector. So this angle is bisected into two congruent parts, which means that these arcs are going to be congruent. So we can set them equal. So we would have 6x minus 86 is equal to x plus 14. So I'd get 5x equals 100. So x is 20. Then we need to find SM. So I'm going to substitute 20 into both parts. And I would get 34 and 34. So the measure of arc SM, we would need to add those two together. So we would have 34 plus 34, which would be 68 degrees. Number 4, we know that arc FI is 12x minus 10, SH is 4x plus 70, and IS is 48. At the end of this, we want to find what the arc FH is. So in order to do that, first thing we want to do is we want to find x. So we would have 12x minus 10 is equal to 4x plus 70. So we get 8x equals 80, x is 10. Once we know x is 10, we can substitute in, and we get that these are both 110 degrees. So to get the measure of FH, we would do 360 minus the arcs we know, so minus 110 minus 110 minus 48. And we would get that our arc would would equal 92 degrees. Now we have a couple of theorems about circles with tangents and perpendicular lines. So if a line is tangent to a circle, then it is perpendicular to the radius drawn at the point of tangency. So if this is the point of tangency, our radius is going to be perpendicular. This is going to help us to create right triangles to find missing lengths. So in number 1, we want to find the measure of angle ABD. Well, ABD is going to be a right angle because BD is a radius that's drawn perpendicular to the tangent line. So we would have 3x plus 27 is equal to 90. We can subtract 27 from both sides, so 3x equals 63, x equals 21. In number 6, we have different lengths of segments here. So we know that all radii are congruent, so this is 9 and 9. It's going to be a right triangle because the radius is drawn to the tangent line, so that's perpendicular. So the length of this side we would call 9 plus x. So we can do Pythagorean theorem then to find x. So we have 9 plus x squared equals 9 squared plus 40 squared. Now 9 plus x needs to be multiplied together. So 9 times 9 is 81 plus 9x plus 9x plus x squared equals 81 plus 1,600. So we would get x squared minus 18x, or plus 18x plus 81 is equal to 1,681. So we're going to subtract the 1,600 over. So we would get x squared plus 18x minus 1,600 equals 0. So we need two numbers that multiply to 1,600 and add to negative 1,600 and add to positive 18. So those numbers are going to be x plus 50 and x minus 32 equals 0. So x is negative 50 or x is 32. Now 32 is only going to work because 50 can't be included since that would give us a negative length. Number 7, again, our radii are congruent, so this is x, this is also x, and we have our right triangle. So this whole side is x plus 32. So we'd have x plus 32 squared equals x squared plus 40 squared. Remember, we have to multiply the x plus 32 times itself. So x times x would be x squared. And continuing, we have 32x plus 32x plus 1,024 equals x squared plus 1,600. Now this time there's an x squared on both sides, so those cancel out, and we're left with 64x plus 1,024 equals 1,600. We can subtract the 1,024 from both sides. We get 64x equals 576. So when we divide 576 divided by 64, we would get x is 9. Number 8, we're missing the radius, but we can draw it in to create our right angle, and the radius are going to be congruent, so they're 5 and 5. So when I set up my Pythagorean theorem, this whole side is 5 plus x. So we would have 5 plus x squared equals 5 squared plus 12 squared. So that would get us x squared plus 5x plus 5x plus 25 is equal to 25 plus 144. We can move everything to the x squared side. So we get x squared plus 10x minus 144 is equal to 0. So we need two numbers that multiply to 144 and add to negative 144 and add to 10. So we'd have x plus 18 and x minus 8 equals 0. When we switch the signs, x is negative 18, which would not work as a solution, and x equals positive 8. Number 9, we have a triangle here, and when I draw in my radius, it's going to create it as a right triangle. The radius is congruent, so that side would be 6. Remember, this whole length we combined to become x plus 6. So Pythagorean theorem, we'd have x plus 6 squared equals 8 squared plus 6 squared. X plus 6 times x plus 6 multiplies out to x squared plus 6x plus 36 equals 100. So we can move the 100 to the other side. So we get x squared plus 12x minus 64 equals 0. So we need two numbers that multiply to negative 64 and add to 12. So we would have x plus 16 and x minus 4 equals 0. When we switch the signs, x would be negative 16 or x would be 4, and negative 16 won't work because we'd have a negative length. If there are two segments that are tangent to the circle from the same exterior point, they're going to be congruent. So it kind of looks like a sideways ice cream cone where these lines would then be congruent with each other. So in number 6, we have two tangent lines. So we have x squared plus x is equal to 12 minus 3x. So I can move everything to the x squared side. So x squared plus 4x minus 12 equals 0. So we need two numbers that multiply to negative 12 and add to 4. So we would have x plus 6 and x minus 2 equals 0. When we switch our signs, x is negative 6 and x is 2. In this case, both of these answers are going to stay because they would make our segments positive. In number 8, these two pieces would be congruent, so x is 41. Once we know x is 41, 41 minus 32 is 9. These two pieces with the y and the 9 are also congruent, so we have y plus 2 equals 9, so y would be 7. Tangent lines and circles. So as we talked about earlier, a radius drawn to a tangent line creates a right angle. So in a four-side figure, which is the quadrilateral here, we know that they're always going to add up to 360 degrees. So if we already have two right angles, we don't need to include those. So if we had 360 minus 90 degrees and minus 90 degrees, that leaves us with 180. So x plus y has to equal 180 degrees. So in number 10, these create right angles. So we have x plus 98 equals 180. We can subtract 98 from both sides, so x equals 82. In 11, same thing. We have the right angles, so the other two angles equal 180. So we have 3x plus 25 plus 2x equals 180. We can subtract 25 from both sides, so we get 5x equals 155, and when we divide by 5, x equals 31. Now this last problem is a question from an SAT. So in the figure, point O is at the center of the circle. Line segment LM and LN are tangent, so these are going to be tangent, they're going to be congruent, they're also going to create the right angles where they're intersecting. If the circumference of the circle is 96, what is the length of the minor arc of LN? So in order to find that, first of all, we need to know what this angle is. So if this is 60 degrees, we can subtract from 180 to get 120. Once we know that that is 120 degrees, we know that we're looking for that length. So our circumference is 96 times 120 over 360. So when we multiply that, we would get 32. So the length of the minor arc LN would be 32.